Now let's look at how we're leveraging domain events in the veterinary front desk scheduling app that we've been working with. Again, we'll start by showing you the code, and then we'll debug through it so you can see it in action.
In our appointment class, we're going to record a domain event when certain changes are made to the appointment. So, if we scroll down and take a look at the update room method, you'll see that it creates and saves an appointment updated event. The same is true for the other update methods, like update doctor, update start time, etc. They each will create an appointment updated event and pass it the current instance of the appointment. And then this is saved into the entity's events collection.
In the case of the confirm method, it's similar, but it creates a different event, an appointment confirmed event. Essentially, the appointment entity can trigger two kinds of events directly, changed and confirmed. And you'll notice it only does so if an actual change takes place. Calling an update that doesn't change the current value will not trigger a new event.
Let's take a look at the appointment updated event, and this is similar to the one we saw in the simpler console app in the previous demo. It inherits from base domain event, which is defined in our shared kernel, and it adds a UTC timestamp property called date occurred that is set when the event is created. This can be useful for debugging purposes. The only other property the class takes is the appointment itself. The appointment confirmed event, shown here, is similar.
Notice that these domain events are all defined in the core project with our domain model. For this sample, they're in an events folder in the root. However, in a large application with many events, it might make more sense to put them with the aggregate that they correspond to, in this case, the schedule aggregate. There's one more domain event in our sample, which is the appointment scheduled event. It's similar in structure to the others, but it's actually created elsewhere.
Once you start working in event-driven applications, it can be a bit more difficult to follow the flow of execution in the app where events are concerned. It really just takes some getting used to, and then you'll find it to be second nature. The best way to see where events are raised and where they are handled is by looking at an individual event and examining its references. Looking at appointment scheduled, you can see that it is handled in the API project and in the core project. It is only created inside of the schedule aggregate itself. Let's have a look at where that happens.
In Schedule, the Add New Appointment method creates and saves the appointment scheduled event after adding the appointment to its collection and marking whether or not it's conflicting. Once the schedule is saved, any appointments that have had domain events added to their respective collections will have them dispatched after the save to persistence is complete.
Before we step through the code, let's have a look at one of the appointment scheduled event handlers. The thing to notice is that these handlers don't get created or called anywhere in our code. That's that Hollywood agent again from the Hollywood principle saying, "Don't call us, we'll call you." The event dispatching logic, in this case using Mediator, is what calls these handlers at runtime. But at compile time, nothing references them directly.
Now let's see the flow of domain events in our application when we change an appointment. We'll modify this appointment for my little baby, Samson, and change the appointment from a wellness exam to a diagnostic exam. But a diagnostic exam takes more time, and this will automatically change the duration of the visit, which should trigger a conflict with one of Samson's other appointments. Yes, he likes to go to the vet quite a lot.
The change initially hits the appointment update endpoint. It loads the schedule and the appropriate appointment and calls its update methods. In this case, the only one that has a change is the change to the appointment type. This in turn adds an appointment updated event. Once the change is saved, the event is dispatched. The API project also has a handler, appointment update handler, that responds to this event by sending a message to the Blazor client using a SignalR hub. This will trigger a real-time notification in the app.
What about communication between bounded context or apps using events? Applications and microservices frequently use events to communicate too, but these aren't domain events since they extend beyond a single domain. They're frequently called integration events, and they may be defined as part of your domain or in a separate project or package. For simplicity, ours are here in this Integration Events folder.
The front desk has just 2 integration events. The Appointment Confirm Link Clicked integration event is published by another app and consumed by this one. An Appointment Scheduled integration event is an event this app publishes and another app consumes. It's important that the structure of the published and consumed types match, which is why frequently a shared package is used to define these kinds of events.
We don't have time to dive deeply into distributed application architecture, but one thing you need to remember when designing integration events is that they typically will be enriched and denormalized when compared to a similar domain event. For instance, the Appointment Scheduled domain event just has a reference to appointment, and that only has IDs for the client, patient, and doctor. However, the integration event includes many more details like client name and email, patient name, and doctor name.
The reason for this is to ensure that consumers of the event have enough information from the event to perform whatever actions they need to without having to immediately call back to the publishing app to ask it for more details. You can imagine that the performance of the system would suffer if every time an appointment event was published, one or possibly many apps that were consuming that event turned around and immediately had to make calls to this app's API asking for client details, patient details, and doctor details. Hence, we have a handler that is responsible for taking in a domain event and enriching it with the additional details shown here on the integration event. We'll put these integration events to use in the next module.
The last topic we want to discuss in this module is anti-corruption layers. An anti-corruption layer, as the name implies, helps to prevent corruption in your domain model.
Right. Just like superheroes help to fight corruption, these layers provide a sense of security to your model when it needs to interact with other systems or bounded contexts.
Returning to our mind map, you can see that the anti-corruption layer is used to translate and insulate as part of a context map, mapping between a bounded context and foreign systems.
When your system needs to communicate with other systems, especially legacy applications that weren't written or modeled as well as your current system, you need to be careful not to let assumptions and design decisions from that system bleed into your model. For instance, if the other system's model includes a customer, even if that customer refers to the same actual business customer, it's likely that it will be modeled differently than a customer in your system. It's best to have a layer that can translate to and from other systems' models. In DDD, this is the job of an anti-corruption layer.
Right. Like we mentioned in the beginning of the course, even other bounded contexts in your own system may be different enough to merit having an anti-corruption layer in place to protect the two distinct models from one another. And, of course, legacy applications frequently use very different models from newer systems. An anti-corruption layer isn't a design pattern. However, it's usually comprised of several design patterns. The job of the layer is simply to translate between the foreign systems model and your own.
In addition to translating the objects themselves, the anti-corruption layer can also clean up the way in which you must communicate with the other system. It may provide a facade to simplify the API, or an adapter to make the foreign system behave in a way that is known to your system. You can learn more about these design patterns in the Design Patterns library on Pluralsight.
We're usually most concerned with having an anti-corruption layer in place when communicating with legacy systems. Eric Evans notes why that's important.
Even when the other system is well designed, it is not based on the same model as the client. And often, the other system is not well designed.
Since this is a fundamentals course, we're not going to dig deeply into anti-corruption layers because they can be fairly complex as well as very customized to each scenario. But here's an example structure of one, which comes from Eric Evans' book, showing how an anti-corruption layer can connect your beautiful system on the left with a not-so-beautiful system on the right.
I really like this diagram. I think Eric had some fun putting it together.
Gee, what gives you that impression, Steve?
Of course, in the middle you can see how the anti-corruption layer is using a facade and some adapters but on the right, it's protecting us from a big, complicated interface, some messy classes, and some things we just don't even want to know about.
Right. And of course, your own system is comprised of an elegant class, a very expressive class, and of course, even more good stuff. And maybe even some stuff we should be refactoring as well.
There's no one way to create an anti-corruption layer. Whatever you need in order to insulate your system from the systems it works with is what you should put inside of this layer, which should allow you to simplify how you interact with other systems, ensure that their domain decisions do not bleed into your design, and ensure any necessary translation is done along the way. We've covered some new topics in this module, and there's a few new terms that we want to make sure we review. Domain events are a type of object that actually represents something that occurred within the domain that other parts of the system may find interesting and want to tie their behavior to. And this is a great way to keep your system decoupled and to keep your individual objects simpler because they don't have to know about all of the behavior that might occur when some event takes place.
We also referred to the Hollywood principle, which can be summed up as, don't call us, we'll call you. This principle is related to the dependency inversion principle from Solid and is frequently used to decouple systems from one another. Instead of us putting all the logic we need in our code, we architect the system so that it calls back to us at the appropriate time, and we put our code into handlers that the app calls, rather than directly coupling our model to these actions.
And finally, we looked at anti-corruption layers, which can be used to ensure that our model that we work so hard to produce doesn't become polluted by the models of other systems we work with based on objects they wanted to return to us or the type of API that they want us to code to. So we put anti-corruption layers in place to shield our model from those other systems or bounded contexts that we might work with from our bounded context.
In this module, we introduced domain events, and hopefully you have a good idea of what they are at this point.
We've talked about how you can identify opportunities to use domain events based on the kinds of requirements your customers give you, as well as when you see code in your model that's doing too much and could be more loosely coupled.
We gave you some tips for designing and naming domain events, and then we showed them in action, both in a relatively simple console app as well as in our much larger veterinary clinic sample application.
Finally, we introduced the concept of anti-corruption layers, which use a variety of design patterns to insulate our model from the design choices of other applications or bounded contexts. Here are a number of resources where you can learn more about domain events and anti-corruption layers. Some of these, including a few Pluralsight courses, we mentioned in this module, but there are others that we find to be relevant even if we didn't explicitly mention them.
Up next, we're going to wrap up this course by adding a new feature to the application. Because of our clean architecture and well-designed domain model, it's going to be pretty easy to integrate into our existing app.
I'm Steve Smith.
And I'm Julie Lerman, and thanks for watching this module of our Domain-Driven Design Fundamentals course.